Masteria Education.
Benzene's reactions. Now, all of benzene's reactions happen the exact same way, which makes it a bit easier. To show you the reactions, I'm going to show you one which is universal across examples, and that's basically going from our benzene into nitrobenzene, which is here. Okay, so this will be the first reaction I show you, and this is universal across examples. There are a couple others which are more unique to specific examples, which I'll also show as well, but this one's universal. So with all these reactions for benzenes, I want you to remember 3 steps of what you have to do. The first thing you have to do is the initial reaction. This is basically taking a catalyst, combining it with another molecule to form our electrophile. Now, as a side note, we need to actually know what an electrophile is. And an electrophile is basically defined as a lone pair acceptor. So it's a molecule that accepts a lone pair of electrons. So the first step is to do with generating our electrophile. Now, in the case of making nitrobenzene, the way we generate our electrophile is we use H2SO4 and react it with HNO3. These are both concentrated, which is an important part to remember. When these react, this will form HSO4 minus H2O, but importantly, it will form NO2 plus. And this NO2 plus is essentially our electrophile because it's positive, it can really accept that lone pair. Or that a better word of actually saying rather than lone pair is actually the electron pair acceptor, because it can be a lone pair or it can be more generally an electron pair. So the first step is generating the electrophile. The second step is the actual mechanism itself. So for the mechanism itself, we have benzene, which is here. We have our NO2, which is positive, and what happens is we have this. Now, in mechanisms, this arrow essentially shows electron movement. So what we're showing is the ring is donating an electron pair to my NO2. When this happens, this therefore allows my NO2 to be bonded onto the benzene. Now, nothing's been removed so far, so this carbon is still bonded to a hydrogen. As we said, it's C6H6. But importantly, because we've now lost some electrons from the ring, my ring is now broken, so it looks like this. So what happens is, in order to become more stable, my hydrogen needs to leave. And you see exactly where I'm drawing the arrows, which is quite important. From here, we're drawing it exactly on the ring, and here, we're drawing it from the middle of the bond into the positive center. This will then allow us to form my NO2 and my H+. The final step for all these mechanisms is reforming the catalyst. Reforming the catalyst. Now, the way this happens is, and this will always be the same across the board, we look at this molecule here, the HSO4 minus. We look at this molecule here, the H+, and all we do is we combine them. And then we reform that molecule that was the catalyst at the start, which was our H2SO4. So essentially what we've got now, my H2SO4 has been reformed. And that is actually what the definition of a catalyst is. It's something which reacts, which speeds up the rate of reaction, but it itself isn't used up in the reaction. So this here is the first reaction of forming nitrobenzene. Now,
Thanks for watching our short video.
Before we go on to the
our full
other
video
reactions,
is on our
it's
channel.
quite important to know the name of this mechanism.
Don't forget to sign up to our
So
A-level
there are
revision
3
courses.
types of
The links to
reactions
these
you can
are
have
in the
in organic
description.
chemistry. You can have
And
an
don't
addition
forget to
reaction,
subscribe for weekly
an
content.
elimination reaction, or a substitution reaction. Addition basically means taking 2 things and putting them together. Elimination means when you remove something. Substitution means when you swap something. So this is clearly substitution, because we're taking my NO2 and we're swapping it with that hydrogen. So the way we name this is, we name it electrophilic substitution.
Thanks for watching our short video. Our full video is on our channel. Don't forget to sign up to our A-level revision courses. The links to these are in the description. And don't forget to subscribe for weekly content.